Wow, time flies when we're having fun, and we're already at 3.1 functions, introduction to functions. Okay, so we have a few terms that we want to learn today, so let's go ahead and look at them real quick. The first term is a relation. A relation is just like a relationship. It's a set of ordered pair where the first component are input and the second component are output value. Okay, so a relationship is just anything. Okay, so if I made a number, an ordered pair like this, 1 8, 1 12, 1 16, 1 -2, that's a relation. Okay, it's just a set of ordered pair. No big deal. They don't have to have, one doesn't have to bring the other. It's just if I were to make random points on a graph like this, that's just a relation. Okay? A function is a special kind of relation. Now, not all relations are functions, okay, but all functions are relations, but not all relations are functions. A function is a relation that assigns each input to exactly one output. Okay, so it's a little more specific than a relation. Okay, so each input have to have just exactly one output. So anytime you see 1, you can have great confidence that your Y will be 9. Okay, so 1 can only have a Y output of 9. Okay, remember an ordered pair, when we have ordered pair, the first one is the X, the second one is the Y. Okay, so 2, 3. Anytime we can have great confidence that anytime we see a 2 as an X, 3 will be the Y. Okay? How about 3, 9? Okay? Anytime we see 3, great confidence. Somebody's like, okay, your X value is 3. You know specifically that your Y value is 9. If somebody comes to you and tells you, okay, for this function, 3, I have 12. Well, that is wrong because a function assigns an input with exactly one output. Okay, so the Y values can repeat, but the X values cannot repeat. They cannot have two different things for the X values. So that is the special case that is called a function. A function is a special type of relation. Okay, when we're talking about a function, we have a domain and we have a range. Okay, a domain, another word for domain is input. Okay, what you put in, input. Or it's also called the independent variable. It does not depend on anything. The domain is the input value and it's the independent value and it is the x value. It's always represented by the x. So the domain is the x value. Alright? The range is the output value. So if you put something in the for the domain, you get a range. Something is spit out. So for example, if I ask you, go, if I give you 1 as a domain, what is a range? You can tell me what the range is. It's 9. So that is the input value is a domain. The range is the output value. Okay, so in an ordered pair, the range is the Y, the second value. So the Y is the range. Okay. All right. So questions could ask you to determine if the relationship is a function. When you have ordered pairs, what you're looking for is you're looking to make sure that not all the x's are repeating. So no repeating x value. So I'm looking at this 3, 4, 5, 3. Notice that the x values are repeating and they have different values. Therefore, this is not a function because the function assigns a specific y. Okay, only one specific y. So NF represents not a function. NF is represents not a function, and let's make F to represent is a function. Okay, so on the second one, if we look at it, you're looking at the x's to see if any repeat. All the x's have a unique y. There is no repeating x value. Therefore, this is a function. F for function, not for fail. F is for function. Okay, so for number 3, again, go through it, go through it, go through it. Notice that I have repeating x values, but notice that they give me the same y values. Okay, so therefore, they're trying to trick you here. This is actually a function. Okay, so this is actually a function. Okay, because although they show repeating x values, it shows me that they are the same y. So this is like somebody saying something again, a true statement. So yes, this is a function. All right, so what if they have a map like this? Okay, again, look for repeating x values and see if they give you different y values. So negative 2, 0, 2, they all map to different things. They all map uniquely to something. Negative 2, 0, 2, no repeating x values. This is a function. Okay, let's do another one. So let's call this number 5. And let's have a function map. Let's call this x. Okay. Let's call this x. And let's call this y. And let's say negative 1, 1, 0, 1. And let's say 3, 2, 1. Okay, negative 1, 3, 1, 2, 0, 3, and 1, 1. Okay, so as you can see, okay, make that better. Make that a little better. Erase this one here. Okay, so let's make this the function, and let's say that I have it like this. Okay. Okay, so now if you look at it, the x's, you don't have a repeating x. However, 1 tells you that 1 gives you 3 and 1 gives you 2. So that's a confusing statement. That's not a function because every x has to have a unique y. Well, having a 3 and a 2 for y doesn't mean this is not an exclusive one. So therefore, this is not a function. Okay. Another way we can tell if something is a function or not is by the vertical line test. The vertical line test tells you whether a graph is a function. Okay, so test the graph for function. So for example, we'll learn this by example. Let's say we have this graph. Okay, so let's say use another color. Let's say we have this graph. This would be an example of a function because if you draw a line on any point, let's see, on any point of this graph, if you draw a vertical line anywhere on this graph, so even if you move this line anywhere on this graph, if it only crosses one place, okay, one or less places on the graph, then it is a function. Okay, so this line doesn't matter where I write it on the graph, it only crosses one place. So therefore, this is a function. Okay, therefore, this is a function. Okay, as opposed to if I do this, let's do the same thing we did before. So like this. Okay, so on this one, let's pretend that my x and y axes are really straight lines. Okay, so if we were to go ahead and draw a line on any point on the graph, it doesn't have to be multiple places, it could be just one place. Okay, so if we were to draw a vertical line, let's pretend that's a vertical line. Can't really tell. Okay, on any place on the graph, okay, on any place on the that's cool. Okay, if we took the vertical line on any place on the graph and it crosses more than one place, as you can see on this one, it crosses two places, then it is not a function. A function. Because this is telling you, let's say this was x equals 2. This is telling you that x equals 2, you have two different y values. Let's call this -1, +1, and -1. So this is telling you that at x equals 2, or even at any other point on the graph, that you have two y values, okay? So that fails the vertical line test, therefore this is not a function. Okay, so let's give you more examples of functions and not a function. Okay, so number 3, let's say you had this. So let's say you had a perfectly awesome line like we did before, and then you came here and you had one extra point. Okay, this will be an example of a not function, not a function, because at this one point right here, if you were to draw a vertical line, it crosses in two places. So this is an example of not a function. So at any point, if you draw a vertical line, crosses more than one place, then that is not a function. All right, and that is it for functions.